Hey you guys, this is Mr. Cell, so I'm gone. I had to go to a conference, so you guys need to be good for the sub. If I find out you guys weren't, just know you're not going to like what happens when I get back. In the meantime, however, so you guys will pay attention, that'd be good, to this video. It will help you. It will be on YouTube as well, so you guys can watch it over and over and over until you understand this stuff. In the meantime, though, get started on these two problems, and then we'll show you the answers here in a moment. All right, let's look at number 25. So we got two different fractions, and we need common denominators then because we're adding them. So I would change this one to 4/20ths, and then I would change the second one to 5/20ths. That means that we're comparing the same size parts, right? Because there's 20th size pieces, which means then I can take the 4, add the 5, and my result is 9/20ths. So this is all review. Hopefully you guys remember that stuff. The second one will work very much the same way. There I'm going to use a denominator of 6, so I'm going to multiply the 1 and the 3 by 6. By 2, making that 2/6 minus the 1/6. Well, that means we're comparing the same size parts, so I got 2 minus 1, which would result in 1/6. Alright, so there wasn't any homework because we took a test last time, so just have the sub pass out the worksheets for the notes right now, and then we're going to go over those notes. So go and get those passed out. I'll start on this. I'll give you a couple minutes to do that, get those handed out, and then I'll start reading. So you'll see the first part of the worksheet on the next slide, but I won't start for a little bit. All right, hopefully those are passed out now. If not, we're going to start reading here so you can catch up with us. Naming properties of arithmetic. In mathematics, there are things called properties. You may think of them as rules. There's nothing new in the properties discussed in this section. Everything you expect to work still works. We're just giving vocabulary to what you've been doing so that when you construct a mathematical argument, you'll be able to use language with precision. So in other words, when we say these things in the future, you need to know what they mean. Otherwise, you're going to be really confused. Here's the first one. This is the commutative property, which you guys should have seen before. The sum of both 8 plus 7 plus 2 and 8 plus 2 plus 7 is 17. That's true. The sum of both 13 plus 14 plus negative 3 and 13 plus negative 3 plus 14 is 24. Notice for both of these, the order is changing. We still have the same number of numbers. They're the same numbers, but we're changing the order. But notice as well that, like on this one right here, we didn't change that to subtraction just like we didn't here, because it doesn't work for subtraction. This only works for addition, and then radian multiplication. So you guys can take a moment, look at those, and then the last paragraph there, the word commute means to travel or change. It's most often used in association with location. For example, we say people commute to work. All right, which pairs of expressions are equivalent? So this is starting the worksheet there with some of these problems. 12 plus 4. And then also, we've got this 4 plus 12. So are they the same? I mean, we could check, right? 12 plus 4 is 16, and 4 plus 12 also is 16. So these two are equivalent. All right, what about these ones? Again, let's go ahead and check. 9.8 minus 3.4. I mean, if you want to stack these, right, using the place values. 3.4. If we subtract these, we get 6.4. Well, what about this one? See, now I've got a positive, and I'm taking away more negatives. And if you did the subtraction there, you'd get negative 6.4. Are these equivalent? No, they are not equivalent. All right, take a moment, and what do you think about this one? So we can see that 12 minus 4 would be 8, and 4 minus 12 is a negative 8, and hopefully you guys are seeing a pattern there. They have the same absolute value, but their actual values are different, so they're not equivalent. All right, take a moment and try this one too. And as we can see, these two are equivalent. Both of them equal 20. Now keep in mind the property we talked about, right? We did talk about the commutative property. The order of these two has changed. 5 times 4, 4 times 5, or in more foundational terms, 5 groups of 4 and 4 groups of 5. They're the same thing. All right, take a moment and figure this one out, and then figure out if they are equivalent or not. As we can see, 3 times 0.9 would be 2.7. And 0.9 times 3 also is 2.7. They are equivalent. All right, try this one out. Now we have two that are not equivalent. 18 divided by 6 is 3. And if you did long division for 6 divided by 18, you'd get 0.3 repeating there. So what pattern are you noticing? Well, the answer you found obviously is that you can change the order of addition and multiplication and get an equivalent expression. But you cannot do that with subtraction and division. So the commutative property works only for addition and multiplication, like we said before. Well, what about the associative property? The word associate means partner or connect. Most often we use the word to describe groups. For example, if a person goes to Eastmont Middle School and not Indian Hills Middle School, we would say that person is associated with Eastmont Middle School. It's also kind of like your friends, right? You associate with your friends. And we'll kind of use that as an example here. Here's an example of the associative property. So when we look at this grouping stuff, right? So like here we're grouping 17 and 4. And by the order of operations we'd have to do that first. But you've also got your friends 3 and 16 over here. And well, if you combined this group of friends and made that 3 plus 17 and you group this group of friends, 4 plus 16, it's not going to make a difference in terms of who your friends are. Right, and in addition to that, it didn't change the order of the friends. So you got 3, 17, 4, 16. But over here you got 3, 17, 4, and 16. So just keep in mind the associative property does not change the order of the values that we're operating on. And then same here with multiplication. If I do 2 times 5, again, if I look at my friends, 2 and 5, and group them first, and then if I go to my friend 3 in terms of multiplication, it's not going to change if I were to go to 3 and 5 here first and then 2. The answer to both of those is 30. So looking at the next few problems, for each of the following pairs of expressions, the operations are the same, but the constants have been associated or grouped in different ways. Determine if the pairs are equivalent, be able to justify your answer. All right, well, let's go ahead and do these two. So 12 plus 4, that's going to give us 16. And then if we add this 6 out here, because I'm doing this by order of operations, right, I get 22. Well, 4 plus 6 is 10. And if I take 12 and add that 10, I still get 22. So these two are equivalent. Take a moment and try this one then. See if these two are equivalent. Bam, there you have it. This one should produce a 15.4 for both of these. So they are equivalent. All right, take a moment and try this one. Again, you'll be using the order of operations. And clearly these ones are not equivalent. this first one here is going to produce 5, and the second one here will produce 11. Very different answers, so they are not equivalent. All right, take a moment and try this one too. And clearly these two also are not equivalent. All right, take a moment and try this one. And yes, now we have equivalent statements. 5 times 4 is 20. If we multiply this by 1/2, we get 10. Well, down, up, and count. I got 4 times 1/2, which is 2. 5 times 2 is still 10. So these two are equivalent. All right, take a moment on this one with a little bit of division. And here we can see that these two are not equivalent. 18 divided by 6 is 3. Then if I divide it by this 3, I get 1. Here I've got 6 divided by 3, which is 2. And 18 divided by 2 is 9. These are not equivalent. All right, take a moment and try this one too. Yes, these two are equivalent. All right, try this one as well. All right, and we can see that these two would not be equivalent. Again, with the division there, it's working a little bit different. So what you need to do is think about why. Why is the multiplication working and the division is not? And that's notice about the problems that were given. And you probably noticed this addition and multiplication can be grouped in different ways and still give the same result. This is not true of subtraction and division. Now, this property, of course, is the associative property, and we found that it worked for addition and multiplication, but not for subtraction and division, which is what this is saying. The word identity has to do with sameness. We use this word when we recognize the sameness between things. For example, you might say that a Halloween costume cannot really hide a person's true identity. Above, we defined the associative and commutative properties for both addition and multiplication. We need to do the same thing for the identity property. So the identity property is really just asking for us to figure out what do we have to do, what operation are we using, and what do we have to do with that operation to get the same thing out. Okay, so you'll see this in the examples. So go and take a moment and write down what do you think the identity property for addition should mean, and then give some examples. Well, if we have a number, let's look at an example for 20 there. So something like the number 5 right here. 5 is a nice number. Well, if I were to add something to 5, I would need to give 5 back. That's the identity, because 5 is, and this may come as a surprise, 5. So what do I have to add to 5 to get 5? Well, the answer, as many of you know, is 0. And it doesn't really matter where I put that. So let's say that I had another number like 7, right? Well, if I wanted this to equal 7, then I could take 0 and add it to 7 as well. And it's still going to be the identity property. So it doesn't matter where we add the 0, as long as we are adding the 0. So hopefully that's what you thought it meant, because that is what it is. All right, take a moment and figure out what you think the identity property for multiplication should mean, and then give some examples. Again, it's very much related to addition, but we'll probably be using a different number. All right. So let's look at an example. Okay, it's the same idea. Let's use a different number though, like 10. 10's a nice number. And I need to multiply 10 by something to get, again, the identity 10. What is it that you would multiply 10 by to get 10? 1. Anything multiplied by 1 is itself. Now you have to be careful, because when we say, if we multiply anything by 1, what do we get? Some of you say 1. No, that's not the case. Anything multiplied by 1 is itself. So if we used a different example, even a negative, let's use a negative 4. Well, what do I multiply negative 4 by to get negative 4? I would multiply this by 1. So the identity property for multiplication is when we multiply something by 1. Now this changes as well, so let's look at another example. Let's say that I had 8. Well, if I multiplied 8 by 1, then I get 8, right? Well, it's the same idea for fractions, but I can change 1 to be a fraction as 1 over 1. But what else equals 1 over 1? Again, I have an equivalent fraction, something like maybe 3 over 3. Well, how does that change our answer? The value is still 8, but it changes the way the 8 looks, right? So I could make that 8 over 1. 8 times 3 is 24. And 1 times 3 is 3. See how we have an equivalent fraction here to 8? So we may end up doing that, and we will do that in some cases. And this is kind of how we were simplifying some of these, some of the fractions from the past, is instead of multiplying the 8 by 3 and the 1 by 3, we may have divided by some value. So what is the identity property of addition? It's A, which would be any value, plus 0 is the same value, A. What is the identity property of multiplication? It is when we multiply a value by 1, which is shown right here, which is a little bit what they call abstract, meaning A can be any number. Let's look at the inverse property. The word inverse means opposite or reverse. You might say forward is the inverse of backward. There's an inverse for both addition and multiplication. What do you think should be the additive inverse of 3? Well, if you had 3 what is its inverse or opposite? Its opposite we know is negative 3. So if I added this thing together, what would I get? 0. So when we use addition, the answer should be 0. What does that mean for multiplication? So let's look at this example with number 27. We have the multiplicative inverse of 3. Well, the multiplicative inverse for multiplication is going to produce 1, not 0. Because we could multiply anything by 0 and get 0. So what is it that we would multiply 3 by? Well, as a fraction, we would just have the denominator be 3 and just make that 1. So really all we did is we took 3, the value that we had, and the multiplicative inverse is like making this a fraction, 3 over 1, but then we flip this or reciprocate it to be 1 over 3. And that's what the multiplicative inverse is when we multiply a value by its reciprocated value. Notice we're not looking at an opposite here, so be careful on that. What about 26? What do you think would be the additive inverse of negative 3? Let's write this out, negative 3. So now we're looking at additive inverse, so we need to add something to negative 3 to get 0. And to get that, all we need to do is add its opposite, which is 3. It's kind of like looking back in the first unit when we had 0 pairs. This kind of is a 0 pair. I've got 3 negatives and 3 positives. If I combine them, I have those 3 0 pairs. But if I look at these as 3's individually, then I have 1 0 pair. So these 0 pair out and give us a 0. That is kind of what the additive inverse is, which is why it's so important that you understand that 0 pair stuff, because we're going to be using this a lot later on. What do you think would be the multiplicative inverse of 1/3? Well, let's write 1/3. So again, this is multiplication, so we are going to multiply this by something to get 1. So again, I would just flip that fraction to be 3 over 1, and then we would find if we would multiply that out, we would get 1. So take a moment. What is the inverse property of addition? Abstractly, this is the way we would write it, and let's include the multiplicative inverse property as well. Alright, so here's the list of all the properties. We're going to keep this up so you guys have some time to copy this stuff down. So here's the next part of that. If you didn't get all of that other stuff, you may want to watch this video on YouTube so you can get it all down. This is all stuff you will be tested on.